Today, this video is a basic introduction in how to convert your numbers from one number to a different number. Um, in chemistry, one of the main things that we do mathematically is actually change one type of measurement into another type of measurement using some kind of relationship. So in the end, because of what we're studying, the atom, if you know some relationships, you can actually convert between volume and mass using conversion factors. Okay, so today we're essentially going to look at what conversion factors are and how you use them. This unit will utilize the metric system as examples for conversion factors. I know you can probably do this math differently. But what I'm asking of you is that you learn how to practice this when we're doing something that's not that hard. So later when we're doing something a little bit more challenging, you already know how to do dimensional analysis, and all you have to learn is the new material. Okay, the math is fine, you're just learning the new material. One thing I would recommend with learning the metric is to find some kind of mnemonic to potentially remember the order of the units, because if you know the order of the units, then the numbers go in order, like 3, 2, 1, 1, 2, 3. So there's some story on the internet about King Henry, and this is a mnemonic then. King Henry died unexpectedly drinking chocolate milk, where it's kilo, hecta, deca, base unit, deci, centi, milli. This doesn't include all the ones you need from me. Perhaps you want to make a larger mnemonic, but on your test, you can write all over your test. You can always write your mnemonic and all the numbers before you even take your test. Okay, so it's something that I recommend when you're studying. Okay, so this is basically what I've already said. We need to be able to convert between units. We're going to use dimensional analysis, also called the factor label system, but basically both of them just use conversion factors. Okay. The deal with conversion factors and why I will emphasize using them in this unit is that it takes away the thinking. It gives it all to you. Okay, all you need to do is do the method and you will get it right every time. Okay, it's pretty slick. So what is a conversion factor? You need to be able to make a conversion factor first before you can use dimensional analysis. So here's a simple illustration of something you already know. Okay. 1 dozen is 12 donuts, right? So a conversion factor for 1 dozen and 12 donuts is that for every 12 donuts, there's 1 dozen. If you put those two numbers over each other, basically that's like putting 5 divided by 5. And you know if you take 5 and divide it by 5, the answer is 1. If you put two numbers that are quantitatively the same, meaning they have the same value, their dividing will equal 1. Meaning now if we use those to convert between units, we multiply whatever number we have by a conversion factor. Essentially we're multiplying by 1. So you're not changing the value of your number, you're just changing the unit. Okay? That is why we can use conversion factors. Yeah, you'll end up with a different number potentially because multiplying by 12 will give you a different answer, but value-wise, they are of the same value. Okay? And that is what a conversion factor does. It allows you to convert from one dimension to a new dimension using a relationship that you know, like 12 donuts is 1 dozen. So to solve this particular problem, how many donuts are in 3.5 dozen? If you take 3.5 dozen and multiply by your conversion factor, you're essentially multiplying by 1, but it will allow the units to change. Okay, and I'm going to show you how this is done, but I'll just say it. You multiply by your conversion factor, put the unit that you begin with as the unit for the bottom, put the unit you're changing into on top, put the numbers of the relationship in their respective places, and multiply. So the answer is 3.5 times 12, but you used a conversion factor to get there. So how do you use conversion factors? Number one, you need to know the relationships. Either I'll provide the relationship to you or you will need to memorize it. That is why you're memorizing all of those relationships in the metric system. Like kilo is 10 to the 3. What that means is that for every 1 kilo, there is 10 to the 3 base unit. So 1 kilogram, 10 to the 3rd grams. 1 kiloliter, 10 to the 3 liters. So here's how you start, and this is what I just did. In order to convert from one unit to a new unit, you start with what you're given. You multiply, you set up your conversion factor, and you set it up so that units cancel. So I ended up putting dozen on the bottom here because if you multiply by this, essentially this dozen being on the bottom means you're dividing by the word dozen. And if you take the word dozen and divide by the word dozen, they go away. Okay, they cease to be, meaning by multiplying by this, the unit I end up with is just donuts. And that's what we want. Okay, we want just donuts. So let's do a couple other examples. We'll do how many inches are there in 5.15 centimeter, and we'll do how many cups are there in 1.10 liters. So how do you do this? You do it the same way every time. No matter what unit of study we're doing in chemistry, if we're doing conversion factors to get to dimensional analysis, you will do this the same. Step 1, write down what you are provided with. I am provided with the fact that I am converting 55.15 centimeters. Multiply, you will multiply by a conversion factor. What is my conversion factor? Well, I know it's going to be something on top and something on the bottom. I know I want to get to inch. Now I'm providing you with a relationship, 1 inch equals 2.54 centimeters. So that is a conversion factor I will use. My conversion factor will either be 1 inch divided by 2.54 centimeters, or it will be 2.54 centimeters divided by 1 inch. Your job is just to figure out which one. Here's how. It's given to you. You are beginning in the unit of measurement, centimeter. To get centimeter to go away, you need to have the unit of measurement, centimeter, on the bottom of your conversion factor, which means you're going to put inch on top. What is the relationship? Well, for every 1 inch, you have 2.54 centimeters. You will get a point on the test just for doing that. Just for doing that. Now to do the math. To do the math, you'll take 55.15, multiply it by 1, divided by 2.54. Your final answer for this one is 21.7 inches. Centimeter went away, you have inches left. That is your final answer. Our next one is about cups. How many cups are there? Okay, so if I have 1.10 liter, the question is cups. Write down what you start with. You're going to multiply, you're going to make a conversion factor. Automatically, you can put the unit of measurement that you're beginning with onto the bottom. Now, I want to go to cups. Okay, perfect. I'll go to cups. Oh, wait. If you look at the relationships I gave you that 1 liter equals 1.05 quart. And I gave you that 1 quart equals 4 cups. So, right now, do you have a relationship of liter to cups? No. Your relationship of liter to quart. But you also have a relationship of quart to cup. And with those two relationships or conversion factors, you can get to the final answer. So I can't go straight from liters to cups. That's life. But I can go to quart. Because I have a relationship that for every 1.05 quart, I have 1 liter. So liter's gone. And now I'm in quart. I'm not done, because that's not the unit of measurement I wanted for my final answer. All you need to do then is use more than one conversion factor. Okay? Quart comes down, because that is now the unit of measurement you are in, and you will make it into cups. with the relationship of for every 4 cups, you have 1 quart. That is worth 2 points. 2 points just for doing that. Awesome. So now if you do the math, 1.10 times 1.05 divided by 1 times 4 divided by 1, you'll get a final answer of 4.62. Oops. Oh yeah, we'll